Alright, welcome back again. Here we go. This is multiplying and dividing polynomials by monomials, part 2. But first I'm going to continue on actually from where I left off here, from part 1. This is, I wanted to show you, if a question is asking you to make a division sentence for the multiplication above, let's say, from here. Okay, we multiplied this. Now they want you to turn this into a a division. All you got to do is take the answer and you divide that by the monomial that we used. Okay, because this is dividing polynomials by monomial. Okay, and again, as far as division or multiplication sentence, grade 9s, we really do need an answer. You can't just say this by itself is not a division sentence. It needs an answer. Okay, so there's your answer. This is a complete division sentence right here. Okay, and now that we're getting into dividing polynomials by a monomial, I wanted to remind you again by another law that we studied in powers and exponents, and that's the quotient law. So when you're dividing powers of the same base, what do you do with their exponents? You subtract it. Okay, as in, for example, c squared divided by c, well, that'll be c to 2 minus 1, which gives you c. Okay, and I did demonstrate that here. So if you were to divide negative 8c squared plus 12c divided by negative 4c, take each of those numerators above and divide them by the monomial 4c. Okay, and see how I separated the coefficients. Negative 8 divided by 4, negative 8 divided by negative 4, sorry, is positive 2. And c squared divided by c is c squared minus 1. And so the result for this would be here. And then this one is just 12 divided by negative 4, which is negative 3, and negative 3 times 1, where c times c divided by c is equal to 1. Well, that just goes to negative 3. Okay? There was also another diagram that I forgot to show you in part 1. So if they gave you this time this is a different diagram, so I call it other diagram, so it's called the area model. Okay, so what if they just gave you a rectangle and divide it into two pieces? Well, this 3x plus 4 can divide it into two pieces, really. This is 3x over here and there's a 4 there. Well, really, again, you're still using distributive property here. You're really going to take 2x times 3x, so that'll give you the area of A, rectangle A, which gives you 6x squared, so this will be 6x squared. And then you're going to take 2x multiplied by 4 right here. Okay, 2x times 4 is 8x, so this is 8x. And altogether, then the result is 6x squared plus 8x. So this is just another way of showing how to multiply binomial by a monomial. Okay? Yeah, so that's the other diagram that I meant to show you from the other video. Today, now we're here. Okay? We're dividing polynomials by a monomial. So here's our first example, and I will demonstrate this again using loose leaves here, starting with this first example. So how do you divide a monomial? This is just a monomial divided by a monomial, by the way. Okay. Again, I'm going to do this. I'm going to demonstrate this. I'm going to show you what's going on here on loose leaf. Okay, so I'm going to draw these set of tiles first. The first thing I'm going to draw is the array again. But first, I'm going to draw my 8x squared inside here, because this is really, you know, what's inside, which is your 8x squared. The 4x is going to go up top. Like so. So if this is my 4x and this is my 8x squared, what is this? What do I have to draw here? Okay, what is this set going to be? Okay. Well, probably guessed that what do you have to multiply this x tile to get an x squared tile? Well, you're going to have to multiply it by another x. What do you have to multiply this x tile to get an x squared tile? You got to multiply by an x. So this is actually our answer right here. 2x tiles. Okay, and I guess that's pretty much what I tried to demonstrate in the notes here. Okay, so I drew, well, the diagram drew the 8x squared first, and then it drew the 4x up top. And so what is this going to be equal to? That'll be in your next page. Well, that'll have to be 2x, because x times x now will prove that this is x squared, and you have 8 of them. So, okay. Now the polynomials. What is going on here? Well, I'm going to demonstrate this on loose leaf so that you know exactly what's going on from beginning to end. Okay? So here it is again. We did the tiles, now we're going to do the polynomials. 8x squared divided by, 8x squared divided by 4x. But really all I'm going to do is I'm going to divide the coefficients, 8 divided by 4 here, and I'm going to divide the variables, x squared divided by x. Okay, oops, like so. And again, the quotient law states that when you're dividing powers of the same base, it's 8 squared, x squared divided by x, you subtract their exponents, right? So this will be 2 minus 1 over here, which gives me x. This one is just 8 divided by 4, which is 2. 2x. Okay? Now let's get into this example. A binomial divided by a monomial. Negative 6w squared plus 9w divided by 3w. Okay? And there is the tiles there in the notes, but I'm going to start that from the beginning using loose leaves. So here's our next example. Negative 6w squared plus 9w. This might be a lot of tiles, divided by 3w. Okay. So again, how do you do this using tiles? Well, one of them in the array is going to be missing. Okay, so I'm going to draw it like this. I'm going to draw this negative 6w plus 9 inside the array first. Okay, so what does that look like? Well, I'm going to draw my 6w negative like this. And yes, I know this one does actually kind of ask you, it's kind of like it's already asking you to predict how you're going to draw it, because dividing this into 3, well, I think the 3w is going to have to go up here, like so. Okay, so this is my 3w, and you're probably guessing you're going to have to multiply the w with another w to get a w squared. Okay, by the way, this is negative, so what do you predict might, oops, sorry about that, let's stay on camera here. This is my 3w, this is my 6w squared. Okay, I haven't drawn the plus 9w yet. You can probably already predict what this tile is going to have to be to get yourself a negative w squared tile. Okay, but let's keep drawing this binomial. The 9w, well, that's positive, so again, it's almost like you need to know like how many columns you're going to need for the final answer. Okay. So there is my 9w. So what do you predict what tiles might we have to draw over here on this side? Remember 3w, we have our negative 6w squared plus 9 over here. Okay, so a positive w tile times, I'm guessing, a negative w tile. The positive times a negative will give us a negative w squared. And this is probably going to have to be a negative as well, negative w, because the negative times a positive here will give us a negative squared tile. What about here? What do I have to multiply a w to get a w? Well, probably a 1. The same thing over here. Because a 1 times a w is just to give you a w tile. Correct? So yes, here's our answer. Our answer here will have to be negative 2w plus 3. And we'll see if our answer is correct, when we do the polynomials. And this is why they want you to do the tiles and the polynomials, to see if they both, your answers in the tiles and the polynomials actually match. Okay? So how do you do the polynomials for this? Okay? So here we go. Negative 6w squared plus 9w, dividing that by 3w. Well, really all you're doing is you're taking each of these numerators up here and you're dividing them by this denominator. So I'm going to take negative 6w squared divided by 3w plus, in addition to, I also have a 9w divided by 3w. Okay? I'm running out of room at the bottom here, so I'm going to continue up here. Okay, so this is all I'm doing. I'm going to divide the coefficients, negative 6 divided by 3. And I'm going to take the w squared divided by the w. Okay, I'm also, can't forget this part, which is just 9 divided by 3, and w divided by w. Okay. Oh, by the way, in case you didn't see, I just simply got rid of these w divided by w, because what is w divided by w? Well, it's just equal to 1, right? Well, what's 1 times anything? Well, whatever that anything is that you're multiplying it. Okay? That's why the w just disappeared. Okay? So negative 6 divided by 3 is negative 2. A w squared divided by w, remember the quotient law. When dividing powers of the same base, I'm going to demonstrate this up here. Okay, I know I don't write a 1 there, but there is a 1 there. And you just subtract the exponents, right? 2 minus 1. Okay? And so that's what we get here. W squared divided by w is just w. 9 divided by 3, that's just 3. And again, this w divided by w just disappears because anything divided by itself is just equal to 1. So what's 3 times 1? It's 3. So that's why I don't bother writing anything else. So this is our final answer for that. Okay? Again, please pay attention to how things are demonstrated in this video, step by step. If I ask for tiles, then you're going to have to demonstrate both. I guess in case of division, make sure you circle this answer that we have for division. Okay, for a division answer. Okay. And make sure you do the polynomials as well, if and when it asks you for tiles and the polynomials symbolically. Okay, so that's it. It's 5.6, and I wish you luck. I hope this video does help, and for it to help, you're gonna have to view it, but otherwise, yeah, comment, like, and subscribe. Have a good day.